Hey math students, in this video we're going to interpret solutions to linear systems from the graph. The solution to a linear system is the point of intersection. So let's look at this example. The graph below models the cost of renting video games with a membership in Plan A and Plan B. So this graph right here is a linear system of equations because we have two equations that are graphed and they have a solution, which is right here, right? This is how we solve a linear system graphically. We find where they intersect, right? So the point of intersection is a point xy that two functions share in the table in the graph. So this point right here is the point where both Plan A and Plan B share for the number of games and the cost in dollars for those plans. So let's take a look and see what that point actually is. Now, if we look at the x-axis first, or the horizontal axis, it's labeled number of games, and we can see that for 4 boxes that equals 8, so 8 divided by 4, that means this graph is scaled by 2 on the horizontal axis. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I'm going to label this, and I'm going to start off with 20 as my number of games, so 20 games. And then I'm going to look at the vertical axis. The vertical axis here is labeled cost of dollars, so how much the video game rentals cost for each plan. And since we see for 4 boxes that equals $20, that means each box, 20 divided by 4, is 5. So this is being scaled by 5 along the vertical axis. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. So that second part of my point of intersection, my second part of my coordinate, is 65. Great. So now I know the point of intersection. I've labeled it on the graph. This is the solution to this system of equations. Now, something that I always like to do, because I know I'm going to have to explain what this solution means, I like to think about, well, what does this point represent in general, right? So the x here is going to be the number of games, and I see that because it's labeled on the horizontal axis. That would be the first thing in that order for that coordinate, is always on the horizontal axis. So number of games is 20. And then on the y-axis, it's cost in dollars. Okay, so that's the second part of the coordinate. It's always going to be whatever's labeled on the vertical axis. Great, so now I know, in general, any point along either of these lines is number of games and cost in dollars. Okay, so now I can record the solution. The solution here is, like we said, 20, 65. That's where those points, that's where the system intersects. And then the meaning is, well, when X games, so 20 games, are rented, both plans cost Y, 65. And boom, you're done. So, little recap. You find the point of intersection on the graph. You think about what each part is labeled based off of the horizontal and vertical axis, so number of games, cost in dollars. Write down your solution, and then just make a sentence. When 20 games are rented, both plans cost $65. Okay, let's look at another example. Okay, example number 2. We're going to go a little faster this time. Lizzie has 30 coins that total $4.80. All of her coins are dimes and quarters. Below is a graph that represents the only possible combination of quarter and dimes she can possibly have to equal $4.80. So it's the only possible one because every other point on these lines would be decimal answers, and that won't make sense. You can't have a decimal amount of quarters or dimes. The only possible answer is where these graphs intersect, and that's at 1218, okay? And how did I get these lines? I modeled the scenario with these two equations, and I created the graphs for them. Okay, so let's think about what does 1218 mean. Remember, you always look at the horizontal axis first, so 12 is the number of quarters, and then you look at the vertical axis, so 18 is the number of dimes, and I have that listed over here. So we can write down that solution. Again, The solution is the point of intersection of your two lines. And then you just make a sentence based off of the scenario and the labels. So 1218, the solution means that Lizzie has X quarters, that was 12, and Y dimes, that was 18 dimes. And I know in this particular situation, this makes sense because 12 and 18, that equals a total of 30. And if I were to plug in 12 quarters and 18 dimes into my second equation, I would get a value of $4.80. So I know I would be right. And that's it. That's how you interpret a solution to a linear system of equations. You just look at the labels on the graph or the description in the scenario, and you make a sentence. Always start with your horizontal, then your vertical axes in your description. Okay?